So a couple of objectives to go over for this training. So the goal of this is to teach you guys how to navigate to the performance pages in Atlas. I am going to be doing a little bit of slideshow and then jumping into demo within the Atlas platform. I want you guys to be able to understand the purpose of each of the performance pages. There's multiple, so we'll be going through each of those. I'm going to be pointing out some of the key metrics on each page that you might want to be paying attention to evaluate how your system's performing, and what kind of insights you can take away from that. I'll share a couple of my own use cases to get your wheels turning about how you might use the performance pages. So at the end, all of you are able to go into Atlas, access the performance pages, use them to better understand your energy usage, how you're performing on your demand peaks, and evaluate your refrigeration performance across all of your facilities. Maybe you have multiple, maybe you have one. This should benefit you across the board. So a couple of challenges I want to call out that this was really designed to tackle. So before, you're dealing with limited visibility into the refrigeration system efficiency. So we have a lot of calculations and models to be able to understand your system efficiency. But previously, that wasn't easy for you to access other than going directly to us. Now that's going to be a lot easier. Energy insights really were often delayed by 30 plus days because you're waiting until you get that billing statement from the utility to see how you did. Also, demand and coincident peak event performance typically required manual analysis. So during a billing cycle, you might not know, hey, where is my demand at? What is my max going to be? Or how did I do on those coincident peak events? Without somebody going in and having to break that down by hand. Also, just having siloed data made it difficult for corporate teams to work with facility teams to align on what's going on site. So this will help you communicate up and down with your facilities to be able to talk about how sites are performing. So now what does this look like? We have a self-service energy performance insights directly in Atlas so that you can go and see how the facilities are doing, which is going to give you real-time visibility into your usage, the power, the demand. How are you doing on your coincident peak events? How's your refrigeration efficiency looking? Also, sites will be able to independently monitor and review all their own data on demand. So they'll be able to find insights on their own, as well as having, other users like general managers or regional maintenance managers being able to look at a bunch of different facilities and see how their data is looking when they have time to do that. So a little overview of what's in the Atlas performance pages. So this includes 3 different performance pages that we're coming out with. Top one being the general facility performance page. This is where you're going to see your energy usage and your refrigeration efficiency metrics. That includes your power trends, what rates the site is exposed to, your kilowatt per ton, so that efficiency metric based on different suction groups, and also for your overall refrigeration system, power versus rate trends, and also some user actions. Coincident peak events, going to be able to see how those are performing. Your site may or may not be exposed to coincident peak events, but if they are, typically what you want to understand is, okay, how have I been performing during those? How is that going to impact my costs in the future? What are the rankings for the events that have happened so far? So, which ones are looking like they're going to be a top event versus how many more slots are there for future events, how you perform during the event, what that cost is going to be. All of these pages are designed to be view-only dashboards. So the whole point of them is to give you information. So this isn't a place where you're taking action or changing things in the system. This is a place for you to understand how your system is operating. So facility performance, demand events, and coincident peak events. Those are our 3 pages. So where are you going to find your performance pages? So before I jump in, I just wanted to talk through this briefly. Those of you that are familiar with the Atlas platform, when you go in, you have a left side pane that you can click on. It's going to come out and it's going to show you different sections where you can access information about your facility. So we're going to be looking at this new performance section here. You should already be able to see this in your system today. So under there, you're going to see where you can click on facility performance. the demand events, and the coincident peak events. So this is right in Atlas. So now I'm going to jump over into demo mode and show you this within some example facilities. So bear with me while I jump around and share some other screens. All right, so reminder here, if your left pane isn't fully pulled out, you can click on this more button and it's going to show you these different pages: facility performance, demand events, coincident peak events. So the page I'm showing right now, this is facility performance. So this is giving you that overview of how is my system doing, how has it been doing. And the nice thing about it is this is fully dependent on the time period that's selected for it. I've picked the last 30 days, but you have the option to look at the last 24 hours, last 7 days, last 30 days, or even custom. If you want to look at, say, the last 3 months, you could go in and see, okay, what did I look like the past 3 months? Different use cases for different things. I think oftentimes our billing periods are 30 days. So typically we'd want to look at, okay, how have we generally been performing, or zoom in on a specific day to see, hey, did I avoid a rate spike, or did I shut down as I planned? So a couple of things to point out here. So I think the first thing that's probably going to jump out to you is this plot right here. This is your power plot. So this is tied in to the grid power that is metered at your facility. So all that power metering we do, it does have a purpose. It allows us to see generally what are you going to be charged by the utility based on. And that's going to be your grid meter. You'll see here, it's not just grid being shown. So the yellow top line that you see that kind of varies here, that is your total grid. We also have a breakdown of refrigeration. So this actually comes from our models and our analytics and determines during each individual time period how much of that overall power use that is happening at that time is attributed to refrigeration equipment. So this is actually a modeled value that we're providing you, so you can get an idea of, hey, how much is my refrigeration contributing to this versus maybe auxiliary power use at the facility. Maybe you have time periods where a lot of people are plugging in battery charged forklifts. Maybe you have electric underfloor heat that's turning on and off. Whatever it is, other sources are going to fall into what we call the non-controllable range here. So that's the difference that's being highlighted here. I think generally what you'll hear is people say it's typically 70% to 70% refrigeration, 30% extra, or not extra, auxiliary. That can range quite a bit site by site, but you should expect to see a gap there that represents the rest of the power use at the facility. Couple of other things you can see here is the next trend down is your actual rate. So the facility that I'm showing here, you'll notice that it has a usage and a max demand rate that we have listed. And the usage rate actually changes. Not all sites are going to have a variable usage rate. This site happens to. So as I move that cursor, I can see at any given point in time, what was the usage rate? What was my demand rate? They have a flat maximum demand, but their usage can definitely vary quite a bit. This would be useful if you're trying to see how well you're avoiding those variable rates, and also just get an idea for how those generally vary day to day. You can also change what's exposed on these trends. So for example, if I wanted to really zero in on that usage rate, because I'm like, okay, I get it, my maximum demand, it's flat. We can choose to toggle on and off the data that is shown here. So now I'm looking at just the usage rate and how that varied. And up top, we also have the option to break out, remove the non-controllable, which would just give us the grid and the refrigeration power. I could say, hey, actually, we just care about refrigeration contribution to the power use and remove the grid. So you have options for how you might want to break that down. We also have the added benefit of being able to look at the modeled power contributed based off of equipment type. So for example, here at this facility, compressors make up the vast majority of the power usage. So that's that purple value. And then you can see this red value, that's our condenser equipment. Our evaporators are this blue, and miscellaneous refrigeration, that might be pumps or other pieces of equipment that don't fit into one of those larger buckets of equipment. So this can be really handy. Say you do a change of compressor sequencing, you might see the compressor's power jump down and up as you have compressor sequencing on and off, or say you change your evaporator requirements in a space and you see increased evaporator usage. That can be interesting to look at in this by device type view. And then we can go ahead and add back the grid and non-controllable. So we can use that at any in any of these situations with grid and non-controllable included or without. All right, so that's our top two trends here. Before I move on to the refrigeration performance, a couple of other items to call out here. These are our big numbers at the top. So number one here being grid power. So you're going to notice we have a big number here. This is going to be your average grid power during this 30-day time period I have selected. It will change depending on the time period that you have selected. So if I did 1 day, it's going to give me grid power for that 1 day. One of the things to note is right below here, you'll see that we have the minimum that was used. So 221 kilowatts for this facility during that time period. That was the minimum grid power they saw, probably during a shutdown. And then the maximum that was used, that peak demand, was 802 kilowatt. This next big number over here, this is going to be specific to the refrigeration power. So like I said, we're able to model out what is the refrigeration power component of this overall power usage I have. So this is going to give you your average during this time period. And again, the minimum and the maximum that refrigeration contributed to it during this time period. Up here, we also have our usage rate. So this number right here, this 0.03 kilowatt hour, this is actually a blended rate. As I noted, this is a variable usage rate facility. So it's going to change over time, but this gives you an overall, this is where it was sitting at on average, that's 0.03 kilowatt hours. But you can see that it actually dipped negative at some point, with its min being that minus $0.02 per kilowatt hour, and its maximum reached up to $0.28 per kilowatt hour. So this can be interesting if you have that market rate to understand, what is that range that I've been seeing in this last period. And if you have flat rates, you'll just see that it sits flat. But this is definitely interesting for those variable facilities. Okay, so that covers our facility performance in terms of power, but let's look at our efficiency. So this is a new thing that we have exposed in Atlas and something I think is super valuable. So the breakdown of efficiency based off of your refrigeration efficiency, your compressor efficiency, and then we also have the cooling load on average. So as some of you may know, we've talked about this in trainings often, or when we're talking about savings. At CrossNoK K, we have models based off of the equipment at your facility and the performance of that equipment that is able to estimate efficiency from your pieces of equipment as they operate in varying conditions. So say your suction pressure, discharge pressure varies. We're able to model the performance of that given the cooling load that is occurring at the time. So that's where these values are coming from. And this is what's newly being exposed to you so that you can look at that and understand, maybe why is my efficiency worse during one time period versus better during another. And for those who aren't familiar with the kilowatt per ton value, lower is better. We want to see a lower kilowatt per ton value versus a high kilowatt per ton value. That means that the power that we're putting into our system is more efficiently handling that heat load that we have to process to keep temperatures at set point. So you'll see that vary. I think one convenient way to use this kind of information is, say you had to switch up your compressor sequencing, bring on a different machine, you can see how much that really impacted your efficiency. Is that a more or less efficient equipment to run? maybe there's a more efficient compressor available that would be better suited for the load that you're seeing at your facility. Over here on the right, this is your cooling load. That is another estimated value that we're able to model. So during this time period, we're giving you your average tonnage throughout the 30 days. But if you look at this actual trend, you can see how it varies day to day. Typically, what you're going to see here, and you guys who work at facilities probably are pretty familiar with seeing, during the weekends, loads typically drop off, and during the peak week times, you see those go up. So you can kind of see some variation. This site is pretty consistent, whereas some sites might have much wider swings in cooling load. So again, this can be really handy to understand maybe load changes in your facility after a use change for one of your rooms. Say you have a room that goes from a cooler to a freezer, you're going to see a change in your cooling load over time. And this can help you analyze your performance for your system or think about how you're allocating which rooms are being used. So you'll be able to break out, okay, how much of an impact did that have? And maybe I'm running with less load, maybe I'm running with more. So this gives you insight into that over time so that you can leverage it and do some of your own analysis or ask questions about what changed. All right, and then our refrigeration efficiency average here. So this is looking at the total refrigeration system. This efficiency value in the middle is just for the compressors. This is taking into account all of the other power sources that go into processing that load. So your fans and your pumps, everything coming together to give you this overall efficiency value. Can be used in similar ways. So this was looking at all of the suction groups combined. You'll also be able to see each individual suction group. So for example, I can break it down to just my low side compressors. Look at the cooling load that's coming from my low side, how the compressors on the low side are looking with respect to efficiency. Same with my high side. How is that load changing over time, and how efficient is that group of compressors operating? Again, this can be kind of helpful. Say you have a two-stage system and you want to evaluate, okay, how well am I balancing this out to balance out the efficiency of each suction group? This can be an interesting way to look at that. But also just give you insight into how these different groups are performing. And then finally down here, you'll see two tables. This system's rather simple, so you only have two compressors shown here that were active during that time. If they had more compressors running, there would be more in this table. But this gives you an overall look at, okay, how many run hours did I have on these compressors? That's your total run hours during this 30-day time period. How many partially loaded hours did I have? Am I running partially loaded for a lot of those hours that I was running? We don't want to be operating at part load often if it's a slide valve machine, though maybe you have a VFD machine. This is just information to help you assess how am I performing. So for example, on the high side, they actually have the compressor 3 down here running partially loaded most of the time. So that could be something where you say, well, should I bring on a smaller machine? This one seems to be oversized for the load. You'd have to dig into the data a little more, but it gives you a direction to start looking in. And then there's some other values here, like your average suction pressure, discharge pressure, power, cooling load, efficiency, COP, and isentropic efficiency during that time period. Again, these are just data points that should help you evaluate why is my system running the way it is and how am I performing overall. All right, there's a lot on this page. And definitely if you have any further questions on this, make sure to add it to the Q&A, but I'm gonna go ahead and move on to some of our other pages. But I do wanna say, I love this page. I think this is a great troubleshooting tool and a great way for people that are looking over multiple sites. Say they have 5 sites they're responsible for. This is a great way to come in and see if there's anything that's impacting power use at a facility and give them a direction of like, I should go dig into this site. Why are they using more power? And oh, this site's actually improving. I don't need to spend as much energy over there looking at it. It kind of can help you decide where you need to be putting resources and just give you a lay of the land really quick. If there's a big change, you're going to see it immediately. All right. So That was facility performance. Now I'm going to go on to demand events, and I'm actually going to hop over to a different site that has demand events that are interesting. So this facility, it actually only has a maximum demand being shown here, doesn't have time of use. I will show you a time of use example. But if you come into this page, what you're going to see is a table that gives you a summary of per month, what was your maximum demand day? So which day did I hit my max demand? And I guess just to make sure everybody's on the same understanding, maximum demand, when we talk about that, that is something your utility charges you for. It's the maximum amount of power that you use during the billing period. And depending on what interval they're looking at, say they're looking at a 15-minute interval, it's the most demanding 15-minute interval during that time period. So what was the maximum amount of power that you asked for your facility during that billing period? And you're going to get charged a specified amount of money based off of a rate for that usage. So what this table is going to tell you is during that time period, so if we look down here, January, on Thursday, January 8th, that's when the maximum demand occurred during that month. This was the time that it occurred, 12:45 p.m. This is how high that power was and what we think that cost is based off of the rate. So taking that 310 kilowatts, applying the demand rate to that and telling you about how much that cost. Now you can see over time, it's kind of varied. They're typically pretty consistent. April is in progress. So obviously April hasn't ended. It's April 23rd, so it is still happening. But so far what they have is April 17th at 11:30 p.m. They actually used a little more power during their max demand than usual. Might just be because of weather changes, but you can see that estimated cost is a little higher. So this is super useful if you're a site that is really diligent about keeping your demand low, or you're a regional manager that wants to see how folks are performing. You'll be able to identify outliers. You know, say this was, instead of 335 kilowatts, they had all of a sudden a 500 kilowatt maximum demand. Like, whoa, usually they're sitting around 300 to 400 with their maximum demand. What happened on that day? And having this day that it occurred and the time that it occurred is going to give you a direction to go look in trending, see why did it spike? Was there manual compressor operation? Maybe the site had an unexpected shutdown and had to recover from that. Whatever it was, this is going to give you the data point to go look at, the time period to look at, and help you understand how much it's going to cost you. So I really like this page. It's very simple, but straight to the point. The next cool thing about this is if you click on view details for any of these events, it's going to pull up the time period during which that happened. So you can get a view on your grid power, the uncontrolled load, and the refrigeration power during that time when that peak was set. So called out here with this red dotted line is that maximum where that occurred. So you can see, okay, like looks like they were working up to that. And it doesn't seem like anything too extreme happened during that time. You can also see here, again, those big numbers. What time did it happen? How much was the power use during that time? What's the rate associated with that? So it's actually $1.93 per kilowatt for this facility. So that tells you how much it costs on a rate basis, and then what that estimated event cost is. Again, this is a similar control as the facility performance page where I could take out the grid and non-controllable. And let's say I want to look at device type because I want to see, well, you know, in some cases it might be that they brought an additional compressor. So you would see that compressor usage jump. For this site, it looks like this was a fairly normal thing. It's just a little higher on average. But there could be more extreme events where you have power use kind of sitting more even and then all of a sudden gets a big jump up. You want to know why it jumped. Was that from my refrigeration system? Was that from my non-controlled load? That's really important information to find out quickly, and this view allows you to do that. All right, and then again, we have the rate value down here. That's so you can understand, was my rate changing? Again, for this site, their max demand rate was flat. Usage varies. And down here, another interesting thing that you can look at is user actions during this time period. So what was leading up to it and what happened after the fact. Looks like there's a lot going on here, so I won't dig into it too much. But this gives you an idea of on that day, what was happening. Did they have a lot going on? Did somebody manually operate a piece of equipment and who did that? So you'll be able to dig into that. All right. Now, I won't go too deep on the time of use because it's basically the same. But for a time of use facility, it's going to look like this. Same information, but some facilities just have both maximum and time of use. So you might want to see, how do we perform during our max time of use periods. So for this facility and most facilities that have that, the goal is 0 during a time of use period, which for this facility, I believe it's 4 to 9 p.m. See, they're getting ready to shut down again. They haven't always been able to hit it. They were able to hit it in March. And this is one way to come in and see if you have a facility like that that has these very high cost time of use periods. How are they performing to hit that? Are they pretty consistently getting 0, or are they having to skip different months? All right. The last page I'm going to show you guys, it's not shown on that one because they don't have coincident peak events. So I'll just hop over to it and show you guys. So this is going to be under peak events. If you're a facility with coincident peak events, you probably know it. If you don't have coincident peak events, this isn't going to apply to you. But for a lot of regional folks and general managers and things like that, this is something they care a lot about. So coincident peak events, depends what region you're in, what utility structure you're on, how this actually applies to your site. So I'm not going to go into detail on this. For those sites that are affected by coincident peak events, later in May, we're actually going to be having some webinars associated with that to educate on how that works and make sure you're prepared to avoid these events. But to give a very brief idea of it, there are peaks that happen during the season. And this page, the purpose of it is to give you an idea of when did those peaks occur, what was the time period associated with them, and how did your site perform during those peak events, and what do we estimate that cost is going to be associated with that performance when your coincident peak rates and tags are set for the following year. Again, for those that have it, they should be fairly familiar with the structure of this. So this site actually has 4 peaks that happen. This is for their capacity events. So right now what we have is they had an event in January and in March. This tells us when that peak occurred for both of them. It was 7 to 8 a.m. So there's a 1-hour window in which these occur. What was the average power during that time? So typically you're going to be charged based off an average of how you performed during coincident peak events that were identified. So say they're looking for the top 4. What was your power on average during those? And then the estimated cost. Now, the estimated cost is coming from rate information we have about the facilities. So that's where that value is coming from. So you'll notice we only have 2 events here, and it's saying these are the events that have occurred. There's actually 4 possible for this facility. So there's 2 remaining slots. So we might have up to 2 additional events occur before the end of the performance window that we're looking at. And we're looking at December through November of this year. If you wanted to look at your performance during the previous season, you could look that up as well. I do not believe this facility has performance during that season. But for sites that have been on Atlas for more than 1 year, you'll be able to look back at your history of how you performed during these different coincident peak event seasons. Because the goal is to, for one, drop how much you're using during coincident peak events, and then maintain that over time, a low power usage during those events. So you'll be able to easily see how have I been doing year over year, both in my capacity and in my transmission events. So when it starts getting into a season where we have a lot of events happening, you're going to see more and more appear on this page. There's going to be the ones that we think are likely, and then there's going to be the ones that are upcoming that we think are going to be occurring. And then those will be selected on which ones we think are actually top 5 or top 4 peak events. So, what's the takeaway from this page? It's really that you're going to have a lot more visibility into how you're doing during the coincident peak seasons, which should be helpful for you to be able to push sites, understand how sites are doing, and for facilities themselves to say, hey, we're actually really nailing it on these. Let's keep that up. Or say, oh, we missed some, but actually, averaging out, we're doing pretty well, but give you something to work towards and be able to see, like, okay, this is how we're doing so far. Similar to the demand events page, you're going to be able to click into the individual events and see how well you performed during it. So they actually performed pretty great during this one. They had the peak time from 7 to 8 a.m. Their average power during it was 91. Their capacity rate sitting around $19.8 per kilowatt. So that estimated cost is around $1,800. So this can be really useful to see, like, okay, well, we actually did really great. Our refrigeration was pretty much at zero. They had a little bit of equipment running, probably maybe on the condenser pumps or something. But overall, they were able to drop their power really low. And you can see down here that coincident peak rate value in there. You also notice before that event, they also had higher usage going into it. So they did a longer shed period to capture both of those values, which is just, I think, interesting to see on here. But yeah, so this will highlight for you, did we hit it? Did we maybe have to restart too early, or maybe we got into it too late? This is an easy way to see how that performed. Okay, so that is a summary of all of the facility performance pages. Let me jump back over to here. Okay, so let's go over some key takeaways. So now you're going to have direct access to your energy performance in Atlas. You're going to be able to go see how you did during those coincident peak events or those demand events. So that's really useful for a site and also regional managers. Also gives you that visibility into the refrigeration efficiency that you didn't have before, and also being able to look at it by suction group and see how those are individually performing. We're also going to have that ability to monitor the demand and coincident peak events and be able to drill down into really what were you doing during that time period? What was each component doing? I think that's going to be really useful for troubleshooting, trying to figure out how you can improve. And overall, this data really just helps users understand energy cost drivers and peak event impacts overall. I think we're trying to demystify what goes into the cost of running your facility. So having the rates there, having the power there, and all those big components broken down, goal of this to help you guys understand what's driving your overall billing cost. And I think just a benefit for everyone is having that easy, direct, on-demand access to their own energy and refrigeration data within Atlas. This makes it a lot easier for everyone, including me as well. I love using these pages so far. It's been really awesome to have that easily available while I'm looking at a site. So, all right.